Let's talk about quadratic equations. They look like this and can be solved with this formula. For the equation to be quadratic, we need to have a polynomial, that is, we have different powers of x. Here is x to power 0, and in front of these we have some coefficients. So a second degree polynomial is there. Also, we need to have that the coefficient a is not 0. If it was 0, then the equation would be just a first degree equation. Also, if a would be 0, we would divide by 0 in the formula. So a, b and c are the coefficients, x is the unknown, a cannot be 0, and we have the solution formula. Let's see an example. Let's solve this second degree equation, quadratic equation. At first we need to find the coefficients a, b and c. In this equation we can add these number ones here to see that a is equal to 1, b is equal to 1, and from the last term we see that c is minus 2. Then we will start to write the formula x is equal to minus b. Well, minus b is minus 1. Then we have the plus and minus and the square root. There we need to put b squared, well that's in this case 1 squared. Then minus 4 times a times c, a is 1, and c is minus 2. And in the end we need to divide by 2a, so we get 2 times 1. This time under the square root we get 9, and square root of 9 is 3. Here in this step we have the plus minus, and we can choose either plus or minus sign there. If we choose plus, then we get this solution. The fraction will be 2 over 2, and that gives 1. On the other hand, if we would choose the minus sign, we would get the solution x is equal to minus 2. Let's draw a picture of the polynomial and let's see what the solutions 1 and minus 2 mean. If we have a second degree polynomial with x squared in the front, with a plus sign, then the graph of the function will look like a parabola, and we have 3 options. First option is that the parabola meets the x-axis, that is the place in the y-axis where y is equal to 0. There can be 2 intersection points. On the other hand, it might be that the parabola is so high that there are no intersection points, or if the parabola happens to be just exactly in a nice place, we get just 1 intersection point. Well, it seems to be that for this polynomial we have 2 zeros, 2 values of x where the polynomial gets the value 0. So because of that we have some picture like this. Let's draw the picture nicely. Let's calculate a few values of this polynomial. Well, we know the 2 roots, so we know that if x is 1, we get, actually we can check here the solution. If we substitute x to be equal to 1, we get 0, as we should get. If x is minus 2, we get in the end 4 minus 4, that gives 0. If x is equal to 0, we get just minus 2. If x is equal to minus 1, we would get minus 2. And let's still pick one value, x equal to minus 1/2. We would get there was a mistake. Let's make all the fractions to be 1/4. And now we should calculate, well, 2 plus 8 is 10, minus 1 is 9. So we get minus 9/4. And by using the calculator, that is minus 2.25. By using these values, we can draw the graph of the polynomial. Let's draw the points into the picture. If x is 1, y is equal to 0. Here is that point, 1, 0. If x is minus 2, y is 0. That point is here. If x is 0, then y is minus 2. If x is minus 1, then y is minus 2. If x is minus 1/2, you can find minus 1/2 from there. Y would be equal to minus 2.25. So we get the point somewhere here. Still couple of more values. If x is 2, y is equal to 4. And if x is minus 3, y has the same value. Based on these data points, we can draw the graph of the polynomial. So let's see. The polynomial will be a parabola like this. And we can observe some facts about this polynomial. We can find the zeros as we should from here and from here. It seems that this value, minus 9/4, is the smallest value what the polynomial attains. And the corresponding value of x, where we obtained the minimum, it was minus 1/2. So the example what we calculated, it has these geometric things related to it.